All right, welcome to another deep dive. We got a request from one of our listeners, you, a medical microbiologist, and you wanted a refresher on diphtheria.
Always happy to dive into the microbial world.
Well, to help us out today, we've got some great sources like Microbiology, CDC, and fascinating historical text from Microbe Canvas.
Sounds like we've got a good mix of the nitty-gritty science and the historical context.
Yeah, so is diphtheria really just a thing of the past, or, are there some things that even a seasoned microbiologist like yourself might not know?
Well, let's see what we can uncover.
Let's do it. Okay, so first up, let's introduce the star of the show, Corynebacterium diphtheria. Microbiology describes it, but what's the deal with this bacterium?
Well, Corynebacterium diphtheria is a rod-shaped bacteria, and the real interesting thing about it is the potent exotoxin it produces.
Ah, the exotoxin.
Yeah, this toxin is like the main reason the disease is so severe.
Gotcha. So Microbiology also mentioned this unique club-shaped appearance, right?
Oh, right. Yeah, it's not your typical round or rod-shaped bacteria, that's for sure.
Yeah, not at all.
That distinctive shape is actually a result of its snapping division process.
Right.
So instead of cleanly separating, the cells kind of remain partially attached, creating that characteristic morphology.
Interesting.
And that's actually really helpful for identification under a microscope.
Oh, I see. So it's a key identifying feature.
Yeah, exactly.
But how does this tiny club actually cause such a severe illness?
It all comes back to that exotoxin we were talking about.
Right.
So diphtheria toxin is an AB toxin.
Okay.
Meaning it has two subunits. The B subunit that binds to host cell receptors, allowing the A subunit to get in there and basically disrupt protein synthesis.
Ah, interesting.
Yeah, and this cellular sabotage essentially is what leads to cell death and, the whole cascade of symptoms that we associate with diphtheria.
The source material, it doesn't shy away from describing those symptoms. Like, it uses some pretty intense language. Thick, gray pseudomembrane, bull neck, even a brassy cough.
Right, and those aren't just like dramatic descriptions.
No, of course not.
They really reflect the toxin's impact on different tissues.
I see.
For example, that pseudomembrane, it's basically a layer of dead cells and inflammatory debris that forms in the throat, often obstructing the airway.
Oh, wow. Okay, and the bull neck, that's from swollen lymph nodes, right?
Yeah, a sign that the body is trying to fight off the infection.
Right. So before we move on, I'm just curious, have you ever actually encountered a diphtheria case in your own practice?
It's pretty rare, thankfully, because of vaccination. But outbreaks do still happen, which reminds us that diphtheria is not just a historical curiosity.
Right, very true.
Yeah.
Okay, so that actually brings us to how this disease spreads. We know respiratory droplets are the main way, but the source also mentioned indirect transmission, didn't it?
Yeah, that's right. So Corynebacterium diphtheria can survive on surfaces for a surprisingly long time, especially if it's moist.
Really?
Yeah, so that means that contaminated objects could potentially transmit the infection, which is why we've got to be super careful about hygiene, especially in healthcare settings.
Yeah, for sure. So if you suspect diphtheria, how do you diagnose it? The CDC outlines both lab and clinical criteria, and they seem pretty thorough.
Yeah, they are, and they have to be because diphtheria can be so serious.
Right.
Clinically, you're looking for that, that pseudomembrane we were talking about, a low-grade fever, and the characteristic cough. But lab confirmation is essential to be sure.
Okay, and they make a distinction between probable and confirmed cases, right? Why is that important, especially during an outbreak?
Well, it helps us act quickly. Identifying probable cases allows us to isolate and start treatment even before the lab results are back.
Oh, okay.
And that rapid response is super important for containing the spread.
Makes sense. So once diphtheria is actually diagnosed, then what's the course of action?
Well, first up, antibiotics.
Okay.
Usually erythromycin or penicillin. But in severe cases, if the airway's blocked, a tracheotomy might be necessary to help the patient breathe.
Oh, wow. And of course, prevention is key, right?
Yeah, absolutely. I mean, as a medical microbiologist, you know how important vaccination is for preventing diphtheria.
Yeah, absolutely.
It's one of the most effective public health measures we've got.
Right, for sure. The source actually mentioned that the diphtheria vaccine is usually given with tetanus and pertussis vaccines and boosters every 10 years, right? But there was this one fact that kind of surprised me. Previous infection doesn't guarantee future immunity.
Yeah, that's true.
Why is that?
It's because the initial immune response from an infection, even though it's protective, might not be strong enough or long-lasting enough for complete lifelong immunity. So those booster shots, they're super important to reinforce that immune memory and provide long-term protection.
Gotcha. So we've talked about the microbiology, the symptoms, how it spreads, how to diagnose it, and even treatment. But where does diphtheria stand today? I mean, I was actually surprised to learn that cases have gone down a lot globally.
Yeah, that's largely thanks to widespread vaccination and improvements in living standards.
Okay.
But, diphtheria hasn't been eradicated, and we can't get complacent.
No, absolutely not. You're right. The source specifically mentioned a resurgence in some developed countries, including Germany, among unvaccinated children.
Yeah, and that just underscores the importance of keeping vaccination rates high and really addressing the concerns that fuel vaccine hesitancy.
Right.
Herd immunity is crucial, especially for those who can't be vaccinated for whatever reason.
For sure. For sure. Okay, so now let's move on to the historical perspective, because our source for MicroCanvas really delves into diphtheria's past, and it's full of these interesting little snippets.
Yeah, it's amazing how history can inform our understanding of disease, isn't it?
Absolutely. For example, did you know that 1613 was known as the year of strangulations in Spain because of a massive diphtheria epidemic?
Wow.
Yeah, and the term diphtheria itself comes from the Greek word for leather, which refers to that thick pseudomembrane.
Ah, that makes sense.
Yeah, pretty fitting description. Bretnow's work, by the way, was crucial in actually establishing diphtheria as its own clinical entity.
Oh, absolutely.
The source also mentioned a diphtheria epidemic in California in 1856, and it was described by a physician named Victor Forgo.
Yeah, his account gives us valuable insights into how diphtheria presented and progressed in those days before we had modern medicine.
Right, right. It's amazing to see how all these historical accounts come together and really paint a picture of diphtheria's impact throughout history. But let's circle back to that question we raised earlier. Could there be a link between societal upheaval and vulnerability to infectious diseases?
I definitely think there's evidence for that connection. Yeah.
The source highlights the rise of diphtheria in Nazi Germany during a time of huge social and political turmoil. And we see similar patterns in other historical periods, too.
Right, like the outbreak in the former Soviet Union after its collapse in the early 1990s, right?
Exactly. Vaccination rates plummeted and diphtheria cases surged.
It's really a clear example of how societal upheaval can make it much easier for infectious diseases to take hold.
It really shows that it's not just about the bacteria itself, but the context, the environment it finds itself in.
Yeah. Factors like war, displacement, poverty, political instability, they can all make populations much more vulnerable to infectious diseases.
Absolutely.
It's complex. You've got weakened immune systems, malnutrition, stress, overcrowding, limited health care, disruptions in vaccination programs. It all adds up.
And with diphtheria specifically, if vaccination rates drop, we see those resurgences like we have recently. It's a reminder of how fragile our progress really is. It's a powerful reminder that public health isn't just about medicine. It's about the well-being of society as a whole.
Couldn't agree more.
And as medical microbiologists, we have to consider these broader societal factors when we're trying to assess the risks and the spread of these diseases.
Absolutely. We have a responsibility to understand not just the pathogens themselves, but the conditions that allow them to thrive.
Well said. So while we've made great strides in controlling diphtheria, it's not a disease we can afford to forget about.
Definitely not. The lessons from its past, both the scientific discoveries and the societal impacts, are really valuable for protecting public health today and in the future.
Absolutely. But hold on. There's still more to uncover in our diphtheria deep dive. We'll be back shortly to explore its lasting relevance and what it reveals about the interconnectedness of microbiology, history, and society.
Before we jump back into diphtheria's history, there's something interesting in the MicrobeCanvas source. It talks about how the naming of Corynebacterium and diphtheria wasn't exactly straightforward.
Oh, like a scientific naming controversy?
Yeah, kind of. So Edwin Klebs, the guy who first identified the bacterium, he initially called it Klebs-Loeffler bacterium.
After himself and Friedrich Loeffler.
Exactly. Loeffler was the one who later cultivated it.
Klebs-Loeffler bacterium, huh?
Mm-hmm.
I mean, it's got a ring to it.
It does, doesn't it? But the name actually went through a few changes over time as, our understanding of the bacterium evolved.
Oh, interesting.
Yeah, like at one point it was called Microsporum diphtheriticum. then bacillus diphtheria, even Mycobacterium diphtheriae for a bit.
So Corynebacterium diphtheria wasn't its first identity, huh? Almost like the bacterium went through a rebranding.
Uh-huh. Yeah, you could say that. And, these name changes really show how scientific knowledge is constantly being refined.
That's a good point. It reminds us that even like established names and classifications, they can change as we learn more. Okay, let's get back to those historical insights. The source mentioned a diphtheria epidemic in New England way back in 1735. Before vaccines, before antibiotics. Can you imagine?
It must have been devastating, especially for children, a time when there were, no effective treatments and parents could only watch as their children got sick.
It really puts into perspective how far we've come in terms of public health, right?
Right.
And before 1826, diphtheria was actually known by different names in different parts of the world. Like in England, it was called Bologna sore throat because it had spread from France.
That just shows how interconnected the world was even back then. Diseases didn't care about borders.
No, not at all.
And it wasn't until 1826 that the disease actually got its official name. Pierre Bretonneau, he called it diphtheriae. That's from the Greek word for leather, which, describes that thick pseudomembrane pretty well.
Leather, huh?
Yeah.
Yeah, it does fit the description.
Yeah. And Bretonneau, his work was so important for establishing diphtheria as a distinct disease.
Right. The source also mentioned a diphtheria epidemic in California in 1856, described by a physician named Victor Forgeot.
Yeah, Forgeot. His account gives us a really interesting look at the clinical presentation and the progression of diphtheria back then. It's like a window into the challenges that, physicians face before modern medicine.
It's amazing how these historical accounts, they really piece together the puzzle of diphtheria's impact, throughout history. But let's go back to that question we raised earlier. Could there be a link between societal upheaval and vulnerability to infectious diseases?
Yeah, there's definitely evidence to support that. Like we were talking about, the source mentions the rise of diphtheria in Nazi Germany, a period of huge social and political turmoil. And, we see this kind of pattern in other historical periods as well.
Exactly, like the outbreak in the former Soviet Union after its collapse in the early 1990s.
Right, vaccination rates went way down and cases of diphtheria skyrocketed.
It's a perfect illustration of how instability in society can create the perfect conditions for infectious diseases to spread.
It's not just the bug itself, but the environment it finds itself in, the context.
Yeah, exactly. So we've got factors like war, displacement, poverty, political instability. All of these can make people more vulnerable to getting sick.
For sure.
It's this complex web. You've got weakened immune systems, maybe from malnutrition or stress, then overcrowding, limited access to health care, disruptions in those vital vaccination programs. It all plays a role.
And specifically with diphtheria, when those vaccination rates drop, we see these resurgences, like the ones we've seen recently. It's a stark reminder that the progress we've made, it's not set in stone.
Yeah, it really emphasizes that public health isn't just about, medicine. It's about the overall well-being of society. It's all connected.
Totally agree.
And for us as medical microbiologists, we've got to be aware of these broader societal factors when we're, assessing the risks and trying to understand how these diseases might spread.
Absolutely. We can't just focus on the pathogens in isolation. We need to understand the conditions that help them to flourish.
Well said. So, although diphtheria is often seen as a disease of the past, it's got a lot to teach us about the present and the future.
For sure.
We can't afford to forget the lessons it offers, both the scientific breakthroughs and the societal impacts. Those are valuable for protecting public health today and going forward.
Couldn't have said it better myself. We have to stay vigilant. We can't let history repeat itself.
Absolutely. But wait, there's still more to our diphtheria deep dive. We'll be back in a bit to look at its lasting relevance and what it tells us about how microbiology, history, and society, they're all intertwined. Welcome back to the Deep Dive. We've been on quite a journey exploring diphtheria from all angles.
Yeah, from the tiny world of the bacterium itself to its impact on history and society. It's been fascinating.
It has. And one of the most thought-provoking things for me is how diphtheria's story goes beyond just the microbiology,
Right. It makes us think about those bigger issues, the social and economic and political factors that can actually influence outbreaks.
Exactly. Like we were talking about before, the outbreak in the former Soviet Union after its collapse back in the early 90s.
Yeah, that was a really stark example of how, upheaval in a society can actually create the perfect breeding ground for these infectious diseases.
It's a powerful reminder that public health is tied to so many things, to the well-being of an entire society.
Couldn't agree more.
So as we wrap up this deep dive, I want to leave our listeners with a final thought. The source we looked at mentioned the rise of diphtheria in Nazi Germany. It said that, and I quote, cases increased after the mid-1920s, doubled again between 1932 and 1937, and reached extremely high levels during the war, only to decline rapidly thereafter. It's a pattern, isn't it? We've seen it with other conflicts, other periods of major societal change.
Yeah, it really makes you wonder, doesn't it? Could there be a deeper link between, societal instability and how vulnerable people are to infectious diseases?
Right. Is it just about healthcare systems breaking down and infrastructure being weakened?
Yeah.
Or are there other factors at play here?
I mean, there could be so many things. Increased stress, maybe compromised immunity because of things like malnutrition, or, even changes in behavior and how people interact that could increase transmission. It's a complex issue.
It is. And as a medical microbiologist, you're on the front lines of this battle against these diseases. What are your thoughts on this connection? What could it mean for your work?
I think it's a really important reminder for all of us that, our understanding of these diseases can't just stay in the lab.
Right, right.
We have to look at the social, economic, and political contexts, too. That's where these diseases emerge. That's where they spread.
Well said. Diphtheria might seem like a disease of the past, but it has some really important lessons for us, for the present, and for the future. By understanding how microbiology, history, and society all connect, we can be better prepared, right?
Absolutely. We can be better prepared to face those public health challenges that, are inevitably coming our way.
And maybe, just maybe, we can prevent history from repeating itself. Thank you for joining us for this deep dive into diphtheria. Until next time, keep exploring, keep learning, and stay curious.